Hello everyone. Now we'll start to talk about Section 2, Object Detection in Google Colab. We'll cover fundamentals of object detection and introduce a framework of object detection called Mask RCNN, and how to implement RCN in Google Colab Notebook, which includes example, assignment, and solution practice. And then take you to Colab Notebook to look at the code in details. So first, what is the object detection? It aims at locating and classifying existing objects in any one image and labeling them with rectangular bounding box to show the confidences of existence. The figure in the right is the predicted image from our Colab notebook. You can see that the trained model gave it bounding box and corresponding confidence about it. The frameworks of object detection can be classified based on the methods. The first method is called region proposal based methods. We have the frameworks of RCNN, region based convolutional neural network, fast RCNN, faster RCNN, and finally the mask RCNN. We will talk about the basic principles of mask RCNN and how to implement it in this section. The second method is the regression or classification-based methods. You have the framework of object detection called You Only Look Once or YOLO, and the Single Shot Detector or SSD. We will take you to look at this single shot detector in Section 3. Another important fundamentals of object detection is to know how to evaluate the object detection model. There are several definitions: confusion matrix and intersection over union here. Look at these figures. The solid box is true or labeled target, and the dashed box is the predicted one. In this situation, it's easy to see that the overlap between true and the predicted is high, which is what we want, the correct detection. In order to precisely define this overlap, we introduce intersection over union. The equations is provided in here. It means that the interaction between the two boxes divided by union of these two. It's very easy to see that the IOU is in the range from 0 to 1. Based on that, we have 4 different kind of situations: true positive, false positive, false negative, and a true negative. So true positive is the same with this image show. The IOU value is above the threshold, is the number we set for the IOU. False positive is if the model gives the predicted bounding box, but the IOU value is below the threshold. For the false negative, if there is truth object, but the object is not detected. And a true negative, if there is no predicted bounding box and no truth objects. And the true positive and the true negative is the correct detection. And this whole matrix is called confusion matrix. Based on that, we have the recall and the precision. The equations for the recall and the precision are provided in here. And we can draw a curve for precision recall. And the area under this precision recall curve is called average precision or AP. And we average all of the classes, we will get mean average precision or MAP. MAP is the most often used parameters to evaluate the model, and we will use MAP in our situation. Then we'll start to talk about one specific framework of object detection called mask RCNN. This image is the principles of mask RCNN. The raw image is processed by backbone. The backbone is usually used CNN structure, and it generates feature map. We have already talked about the feature map and the CNN structure in our section 1. And then we will have the RPN, region proposal network. It scans the feature map and proposing regions that may have objects in them. This is called region of interest. And the ROI alignment, it extracts feature from a feature map based on ROI proposed by RPN and turn them into a fixed size tensor for further process. Those process involves object detection head and mask generation head. The object detection head, it gives us the class and the bounding box. The mask generation head gives us the mask. The object detection head and the mask generation head use the CNN structure, and the CNN is also the same with what we talked about in section 1. The new definitions for mask RCNN is the RPN and ROI alignment and how to interact with what we have already known from the section 1 CNN. Okay, let's talk in general about our Colab notebook. The example notebook is about kangaroo detection. We put a lot of kangaroo images into the mask RCNN model and train it and get the performance using the MAP. Then we use the trained model to predict a new kangaroo images. This image is the predicted one. You will see the bounding box and the corresponding confidence about it. And then we'll have assignment and a solution Colab notebook. It's about amoeba detection. The way to culture the amoeba and how to take the pictures into the microscope and use the Arduino Uno to collect it are provided in our paper and supporting information. So input all of those amoeba images into the mask RCN model and train it. Finally, you will get the trained model and use the trained model to make predictions. This is the predicted image, and you have the red bounding box and the confidence about it. You can use the trained mask RCN model to do more things. The original water drop images are collected by Arduino Uno automatically. I arrange the images so that it's easy to see and it looks like a water drop shape. You can use trained model to find the number and the locations of amoeba in a water drop. You just use your trained model to predict images one by one, and you will get the predicted water drop like here. So in this case, you will find the model detect one amoeba, and here is the location. In the second case, the second water drop, the model detect two amoeba, and this is the locations of it. Okay, and then let's look at our Colab notebook in details. Let's go.